Have you ever been scrolling through Python code and then, bam, you hit a line with underscore underscore init and self and just kind of paused? Yeah, you're definitely not alone. But what if I told you these aren't confusing roadblocks? They're actually the secret ingredients that make Python so powerful and organized. Well, stick around, because we're about to make them crystal clear. Let's get into it. Okay, let's start with something we've all done, setting up a brand new phone. You pull it out of the box, you hit that power button, and what happens next? It doesn't just throw you onto the home screen, right? Nope. It walks you through a whole setup process, one step at a time. You pick your language, you connect to the Wi-Fi, set your time zone, and by the time you're done, the phone is perfectly configured and ready to go. All the essential stuff is already in place. Well, that automatic first-time setup, that is the perfect way to think about what underscore underscore init does for an object in Python. It's that out-of-the-box setup, but for your code. Now, in the world of programming, this setup process has a proper name. It's called a constructor. And in Python, our constructor is the special function named underscore underscore init. The most important thing to get right now is that you never ever call it yourself. Python handles it for you automatically the exact moment a new object is born. This guarantees every single object gets a perfect, consistent start. All right, so we get the big idea. Now let's zoom in and put this thing under a microscope. We're going to take a typical underscore underscore init line and just completely dissect it, word by word. By the end of this, every single piece is going to make total sense. So here it is. This one line is basically the cornerstone of creating objects in Python. I know it might look a little weird with those double underscores and that mysterious word self in there, but trust me, we're about to break it down into really simple, easy to understand parts. First up, def. This one's easy. It's just the Python keyword that says, hey, I'm about to define a function. That's it. Nothing more to it. Let's keep going. Next up is the name itself, underscore init. You see those double underscores at the beginning and end? Python programmers have a nickname for that. They call it dunder. It's basically a secret signal to the Python interpreter. It says, hey, this isn't just any old function. This is a special magic method. And in this case, it's the constructor, the object birth function, and you have to name it exactly like this. And now, we arrive at the one word that trips up almost everyone when they're starting out, self. It causes so much confusion, but honestly, the idea behind it is surprisingly simple. So let's clear up this mystery for good. So what on earth is self? Just think of it as a stand-in for the actual object that's being created right now. It's the way an object can talk about itself. If you create 100 different student objects, each one gets its own unique self that points directly back to it and only it. And that brings us to the most powerful line inside init, the assignment. When you see something like self.name equals name, it's doing two very different things. The name on the right side of the equal sign, that's the piece of data coming in. But the self.name on the left, that's us saying, take that incoming data and store it inside this specific object in a variable called name. It's how we give an object its own internal memory. Okay, that's enough theory for a minute. It's great to talk about it, but let's see how this actually plays out in the real world. We're going to see how init and self work together to let us create multiple, totally separate objects that don't get mixed up. So let's say we create two different student objects, one named Ali and one named Sarah. When we create Ali, self makes sure that Ali and the age 12 are stored inside the Ali object. And when we create Sarah, self makes sure her data is stored inside the Sarah object. They are completely separate. Ali's data doesn't overwrite Sarah's, and that is all thanks to self. So now that the data is tucked away inside each object, how do we get it back out? Simple. We use a dot. When you type ali.name, you're literally telling Python, hey, go inside that Ali object, find the piece of data called name, and give it to me. It's a super clear and direct way to get what you need. Now, you could technically create an object without an underscore init and just add data to it later, but you really, really don't want to. Without it, you're just asking for trouble. You could create objects that are missing important information or that are structured inconsistently. The underscore init method is like a contract. It guarantees that every single object you create will start its life correctly with all the necessary pieces in place. All right, to save you some future headaches, let's do a quick fire round of the most common mistakes people make when they're first learning this stuff. The number one mistake by far is forgetting to put self as a first parameter inside your methods. You have to remember, when you call a method like ollie.greet, Python sneakily passes the ollie object itself as the first argument behind the scenes. If your method isn't ready to catch it with self, your program will crash.
And here's another critical one: forgetting to use self when you're trying to store data. If you just write name equals name inside underscore underscore init, you're creating a temporary variable that vanishes the second the function is done. It does absolutely nothing for the object. To make the data stick to the object permanently, you must assign it to self.
Okay, to really make sure this all sticks in your brain for good, let's use one final powerful analogy. I call it the factory model. This should help you remember exactly what everything does. First, think of the class. The class isn't a physical thing, it's the factory itself. Or maybe even better, it's the blueprint, the master plan for how to build a product.
So if the class is the blueprint, then an object is the actual product that rolls off the assembly line. It's the real, tangible thing created based on that plan. And just like a factory can make thousands of phones from one blueprint, you can create countless objects from one class.
And init? Well, that's a specific station on the assembly line. It's the automated machine that takes each new product as it comes by and performs the initial setup. It installs the software, sets the color, and gets it ready for use. And finally, self. What is self in our factory? It's the unique serial number or barcode that gets slapped onto every single product. It's the label that says, this is phone number 123, and that is phone number 124. It's what makes each and every product distinct from all the others.
So let's tie this all together. Init is the automatic setup function that prepares a new object. Self is the special reference that always points to the current object being worked on. Any data you store with self belongs only to that object, because every object gets its own unique self. And honestly, understanding this is the absolute foundation of object-oriented programming in Python.
So there you have it. You now understand underscore init and self. You have the tools, you have the blueprint to create much more powerful, organized, and elegant Python programs. The possibilities are really endless. So the only question left is, what are you going to build?